this video, we're going to continue talking about topic 8.12, which is volume with the washer method, moving it around other axes. So we're going to look at example 1. We're supposed to set up but not solve. Those are like the most magical words we can actually have on the AP test. We're not actually going to solve this one. We're just going to set up the equation. And when we do take the quiz on this, it'll probably be a lot of that same thing. So involving an set up but do not solve an expression involving one or more integrals that would compute the volume of the solid formed by revolving the region bounded by the graphs of y equals x squared plus 1, which they've already drawn for us, y equals 0, which is the red line, x equals 0, which is the green line, and x equals 1, which is the brown line. But we're supposed to be going about the line x equals -1, which is right here, is the axis of revolution. The area we're revolving is bounded by all of these lines. So this one has a couple of challenges. First of all, we know we have to go in the y direction because I've got this and then this. But I also have two different regions, right? Because look at this. This has the right is this brown line here, and the left is the green. But when I move here, the right is the brown line, and the left is the blue line. So I have to use two different equations for my formula, or for my volume. So I'm going to start, as always, with volume equals pi. It looks like I'm safe to say in this first one I'm integrating from 0 to 1. All right, so now I've got to do my outer minus my inner, just like we've been doing on the other washers. Okay, so my outer function is the brown one. And the brown function we know is x equals 1, so I'm just going to write a 1, minus the inner function, or the axis of rotation. So this is going to be the right. So my right is x equals -1, so minus -1. Then I'm going to go to my left function, which is the y-axis, which is x equals 0. And then I'm going to subtract my axis of revolution, which is -1. Now we are going to add that to pi times the integral, and this time I'm going to go from 0 to 2. We're going to set up our inside function and our outside function. So this was out, and this was in. This is going to be out, and this is going to be in. All right, this time our brown is the outside function because it's further away from our axis of rotation. So we know that that is the line x equals 1. Then I'm going to subtract my axis of rotation, which is -1. So it looks the same as in the other one. The other function is the blue one, but there's a catch. This has to be in terms of y, which I totally forgot to write my dy here. So this should have had a dy at the end, and this should have a dy at the end. Because we're in that horizontal direction, it has to be dy. So I need to solve this for y first, and then I can put that in there. So I'm going to subtract the 1 to the other side, x squared, and then I'm going to take the square root of both sides. So we've got the square root of y minus 1 equals x. So that is going to be my right function. And then I'm going to subtract my axis of rotation, which is the left, and that's going to be -1. You can totally leave it like that if you really must, and you want to put plus signs everywhere. There should be plus signs. You can do that. But again, it said right, but do not integrate. So we're going to stop there.